GECKODRIVE G540 multi-AZ step drive. GECKODRIVE is an American company based in Santa Ana, California. They manufacture all their products in the United States, and this is one of them. Gecko G540 is very popular among the CNC enthusiasts because of its compactness, ease of use, and ability to control up to 3.5 amp step motor, which is huge. I am making 3 parts video of how we use Gecko G540 drive for CNC router. Part 1 is about drive installation and wiring. Part 2 is controller setup with Mach3 CNC software and testing individual devices. And final part 3, is actual use with a CNC router. Part 3 video will be a little late because I disassembled my CNC router for transportation and I haven't reassembled yet, so it will take some time. Let's look at the drive first. It is a 4AZ step motor controller. These 9-pin D-set both connect to the step motor. This parallel port connect to the computer parallel port. There's also a safety charge punch switch at the right corner. At the back of the drive, there's a 12-port connector. Counting from the right, port 1, 2, 3, and 4 are for inputs, can be used with XYZ home switches, as well as a probe to adjust the tool height. Port 5 and 6 are output for the relay. Port 7, 8, and 9 are 0 to 10 volt DC to control the spindle speed if you use the variable frequency drive for your spindle. Port 10 is for disable input, and port 11 and 12 is for drive power. Drive can take between 18 to 50 volt DC. This is enclosure for the drive. It is ABS plastic enclosure, so it's electrically safe. At the rear side of the enclosure, we need to cut the square hole 60 by 142 millimeter cut out to mount the drive. This IEC connector is drive AC input. There's a switch, on-off switch, and also a fuse inside. This AC output is for spindle on-off control. This 9-pin D-set connector is for XYZ home switches and 0 to 10 volt DC power for the VFD drive. And this port is for probe. Front side of the controller, this is a fan to suck out the hot air from inside the enclosure. This is indicator light. This is enable switch or controller e-stop. And this switch is very important, spindle lockout. You know, actually, spindle is very dangerous device and it can hurt people accidentally. So when you need to use a spindle, you just turn on. This way you know your spindle is ready to work. Otherwise, you need to lock out all the time. Let's look at the inside of the enclosure. This is power supply for the drive. So you can use 24 volt, 36 volt, or 48 volt DC based on the inductance of the step motor you are using. So manufacturer recommended square root of motor inductance multiplied by 32 is the power supply voltage you have to use. So I'm using the 24 volt DC power supply because my step motor inductance is only 0.8 millihenry. This is 300 watt 24 volt open frame power supply. It sits inside the enclosure, so it's safe to use. This is the solid state relay to control the spindle on and off. And these two are heatsink. You need to use a heatsink for the drive. So I'm going to mount the heatsink on the back of the drive. You also need the heatsink underneath the solid state relay, so your relay will be last longer with the heatsink. The fan will suck all the hot air produced by the drive and power supply. So as soon as you turn on the power, the fan starts turning and the hot air will be sucking out. Wiring will be simple for both AC and DC. AC power come in from IEC connector and go to the power supply, and one will go to the low side of the solid state relay, and from solid state relay to the AC output for spindle. And DC power from power supply connect to the Gecko G540 drive, and some wire from the drive port will connect to the 9-pin DC connector for home switches and external e-stop, and some of the wire connect to the front switches. Very simple. So let's do the wiring. You need these tools for wiring. So plus and minus screwdriver, a wire cutter, a round nose plier, a wire stripper, and some electrical connectors and crimper, and also soldering iron to properly do the wiring. Wiring is simple for both AC and DC. Before you do the wiring, you need to thoroughly understand the wiring diagram and how system will work. This is the AC part of wiring, and this is DC part of wiring. I'm not going to show you the whole picture of Gecko G540 drive. I just draw the backside 12 port connector we're going to be using for DC wiring. This is IEC connector, this one. AC power connect to the IEC connector, and then one neutral wire connect directly to the power supply. One neutral power connect directly to the spindle AC socket. Also, one ground wire connect directly to power supply. One ground wire connect to the IEC, connect to the spindle AC socket. So the line power, the whole wire, passing through the internal fuse of the IEC connector, and then internally connect to the switch. So the switch output have two contact. One hot wire connect directly to the power supply, and one hot wire going directly to the solid state relay load side. This one. That's all we need for AC bar. For the DC bar, this fan and this indicator light connect to the power supply in parallel. This way, when you turn on the system, the fan start turning, and you will see the indicator light turn on. The port 12, port 11 and 12 of the GECKODRIVE is power supply for the drive. So port 12 connected to the negative DC common, port 11 connect to the 24 volt DC positive. Port 10 is for e-stop. So it's connect to the pin 4 of 9-pin D-sub connector. So it's going to connect to external e-stop. So wire come back from external e-stop, connect to the pin 5, and then inside the controller is connected to the controller e-stop. Now from controller e-stop to go to DC common. So these two e-stop are in series. Port 7, 8, and 9 are for 0 to 10 volt DC. For variable frequency drive, if you use the VFD for your spindle. So those wire connect directly to the port 7, 8, and 9 of the 9-pin D-sub connector. Port 5 and port 6 are for relay control. There's two relay here. So if you need two relay, you can use it side by side. Because some people need to use another relay for their mist or vacuum pump they are using with their CNC router. So my application, I only need to control the spindle AC power, so I only use one. So pin 6, I'm not using it. Port 6, I'm not using it. Port 5 wire connect directly to the spindle lockout switch, and from lockout switch to solid state relay negative input. And positive input connect directly to the 24-volt DC, positive. So this way you're not switching the positive DC. It will protect the inrush. Port 4 we use for probe. So port 4 wire connect to the over here the probe. This is for tool height adjustment, and the other negative wire going to the common. Port 1, 2, 3 are for the home limit switches. So those 3 wire connect directly to the pin 1, 2, 3 of the 9-pin D-sub connector. And from here to we will connect to the limit switches mounted on the CNC router. And pin 6, we need the common DC for the limit switches. So pin 6 is connected to the DC common. We use 2 e-stop in series. One is internal, the other one externally mounted on CNC router. If one e-stop fails, the system will go to fault mode. This is benefit of using 2 e-stop in series. Also, for spindle control, we use solid-state relay instead of normal mechanical relay, because spindle frequently goes on and off. So such an application we need to use the solid-state relay. And you can use the metal oxide varistor across the AC load. The varistor will protect the relay from spike, voltage spike. So this is it. Wiring is done. So let's close the enclosure and power up for initial test. Let's turn on the power. So the fan is turning, sucking out the air. So the hot air inside controller will be sucked out by the fan. So there is also ventilation hole on the top and bottom. So the hot air going out and cool air coming in. So also indicator is on. So this way you know your system is on. Also the spindle's local switch is off all the time. unless you're ready to turn on the spinner head or cutter. So let's look at the back side of the Gecko G540. You see the GECKODRIVE is in fault mode. So this is correct. Why? You see the charge pump switch is on. So this charge pump protect the your CNC from accidentally running. So this charge pump feature waiting for the fault strain signal from the computer. So before you connect the controller to the computer or during the computer boot up, some system accidentally run. So this is dangerous. So that's why GECKODRIVE has a built-in charge pump feature to protect such a thing happen. So let's turn off and switch off the charge pump and turn on again. Screwdriver tip is a little bit. Let me go get the smaller tip. So charge pump switch turn off. So this is the eShop and home and living switches I made it for testing. So let's connect it. Now both e-stops are ready. So as soon as I turn on the system, the drive should go to OK mode, for example, enable mode. So let's see. Oh, see the green light turn on. So now drive is in enable mode. So first, let's try the step motor. So according to Gecko manual, they say in this stage, if you hook up the stepper motor, the drive will hold the torque of the motor. So the motor will be the controller will holding the motor torque. So right now you see that I can turn the shaft. So let's check the AXE first. We'll go one by one. So the binary is correct. Now I cannot turn the stepper motor shaft anymore. It's holding top. Okay, so the AXE is working. We know that AXE is working. Okay, then so this is a XYZ. So let's go with the X first. So stay, grain light is on. Motor holding the top. Camera 10. That's what I will do. Camera 10. Also YAZ. So also YAZ holding the torque. You cannot time. Try the ZAZ. Also ZX is also working. Cannot time. So what are holding the top. So now at this stage we know drive is working. And let's test the e-stop. So because these two e-stops are in serial mode, so one of the e-stop engaged drive should go to forward mode. So red light must be on. So let's try. This is the controller e-stop. So try. Oh, e-stop working. See, one e-stop failed. The drive go to the forward mode. So this is correct. Okay, release the e-stop. And try the external e-stop. This one. Going to mount it on the your router itself. Oh, it's go to forward mode. So it's working. So this is the part one of the how we use the Gecko G540 drive, part one video. So part two video, I'll be setting up the controller with the Mach3 CNC software and testing all the individual devices. At the end of the part 2 video, you'll be able to build your own controller with lower cost possible. So I'm going to show the parts I use for the controller so you can pay for your own. For now, I'm going to stop the part one of my video. I have to prepare for part two video. Stay tuned. So I'm going to stop my video here. Thank you for watching. Peace.